Hello, Precalc. Today we are moving on to section 2.2. So you should have the 2.2 day 1 notes, either the note sheet printed out from Canvas or on your own paper. It's your call. We're going to be doing more with limits. These ones are all going to deal with infinity. So the limit as x approaches either positive or negative infinity. First thing we're going to do is we're going to draw a sketch of f of x equals 1 over x and determine what the limit is as x approaches positive infinity and as x approaches negative infinity. So 1 over x, if you graph that, we've already kind of had that. We know that there's going to be a vertical asymptote at 0 because you can't have 1 over 0. And then if you were to graph this thing, it ends up looking like this. There is another branch over here to the left. It looks like this. And there is a horizontal asymptote here at 0. All right, so that's what the graph looks like. And so when you're trying to find the limit as x approaches positive infinity of 1 over x, you can just look at the graph. As we go to the right, so as we look at this right piece, it's getting closer and closer to that horizontal asymptote, which is 0. The limit as x approaches negative infinity. So as we go to the left, so we're going to use this left branch. If you go to the left, it's approaching that same horizontal asymptote, which is 0. All right, so the limit, whether you go to positive or negative infinity for this particular graph, is 0. Horizontal asymptote, something to be aware of. All right, the line y equals b, so not for this particular problem. The line y equals b is a horizontal asymptote, HA, if and only if, so IFF is if and only if, either the limit as x approaches positive infinity of f of x equals b, so whatever that y value is equal to, or the limit as x approaches negative infinity equals b, or f of x, sorry, I'm missing f of x equals b. All right, so if you have the limit as x approaches positive infinity, it equals b, or the limit as x approaches negative infinity equals b, then we know that that value, b, is a horizontal asymptote. Because a lot of times with graphs, they're going to approach the horizontal asymptote. Usually they don't cross them, but they certainly can. It just depends on the equation. And we did that a long time ago, like first semester. Keep in mind that a graph can have, two horizontal asymptotes. All right, it can have more than one. So something to be aware of is, maybe as you go to positive infinity, it equals one horizontal asymptote, and maybe as you go to negative infinity, it equals the other horizontal asymptote. For this specific equation right here, this one with the 1 over x, since both limits approach the same value, all right, so from here, since both limits equal 0, all right, that means that we know that there's only one horizontal asymptote. There's only one horizontal asymptote. And that horizontal asymptote is, which is y equals 0. All right, for that particular equation. All right, let's look at the next one. For the next one, it says use your calculator to determine the following. And when you use your calculator, you can graph it or you can look at the table. It's your choice. And you're going to identify any horizontal asymptotes. You're going to draw a sketch to justify your answer. So I'm going to skip the graphing it. You can type this in on your calculator and see what it looks like. This is what the graph's going to end up looking like. So spreading out of 2 here, all right, there's going to be a graph that goes like this, and then sprouting out of -2 here, there's going to be a line that goes like this. All right, so that's what our graph is going to look like, and we're finding the limit as x approaches positive infinity and the limit as x approaches negative infinity. So if we go towards positive infinity to the right, we're looking at this piece here, which is staying at a constant value of 2. So this limit is going to approach 2. If we go to negative infinity, so as we go to the left, so we're looking at this left branch, as we go to the left, the y values are staying at -2. So this is going to be -2 here. Notice that these two values are different. That means that there are 2 horizontal asymptotes. All right, we have 2 of them. The one horizontal asymptote is y equals 2, and the other horizontal asymptote is y equals -2. And I mentioned earlier, remember, it doesn't have to, it's not like a vertical asymptote where it can't cross the horizontal asymptote. It is possible for graphs to go through a horizontal asymptote. So this is an example of such a case. Okay, let's go to number 2. It says use limit properties to find the following limits without a calculator and determine any horizontal asymptotes. So notice this one says the limit as x approaches plus or minus infinity. So we have to find both positive infinity and negative infinity. So we're going to do it once with positive. Let's start there. We're going to do the limit as x approaches positive infinity. And what I'm going to do is I'm going to split these up. Okay, so I'm going to find the limit as x approaches infinity of 2 plus the limit as x approaches infinity of 1 over x. All right, these are much easier to find on their own versus combining them with like a common denominator. This one, the limit as x approaches infinity of 2 is just going to be 2. This one, we just did it up above. The limit as x approaches infinity of 1 over x, that's 0. There's a plus sign in between. 2 plus 0, you're going to get 2. Okay, so the limit as x approaches positive infinity of 2 plus 1 over x is equal to 2. All right, so we've got that one down. Then we need to find the limit as x approaches negative infinity. And to do that, I'm going to split it up again. So I'm going to do the limit as x approaches negative infinity of just 2 plus the limit as x approaches negative infinity of 1 over x. All right, and the limit as x approaches negative infinity of 2, it's still just going to be 2 because it's like a constant horizontal line there. And the other one, we found it already up above, it's 0. Add them together, you get 2. So the limit as x approaches negative infinity of 2 plus 1 over x, that's going to equal 2 as well. All right. So we know that there is, it says determine any horizontal asymptotes. Since both as we go to positive and as we go to negative infinity, it equals the same value. We know that our horizontal asymptote, there's only one, it's going to be y equals 2. Alrighty. For number 3, we've got the limit as x approaches plus or minus infinity of sine of x over x. There's going to be 2 ways to do this one. It's your choice. Option 1 is to kind of do what we just did in the last problem. So option 1, I'm going to kind of split this up, and I'm going to do positive infinity first. So limit as x approaches positive infinity of sine of x times the limit as x approaches positive infinity of 1 over x. Okay, so I kind of split them up into 2 terms. Now, the limit as x approaches infinity of sine of x. This one's a little bit weird, okay, because depending on what value you put into sine of x, you're going to get different values. But remember that sine of x, it oscillates. It goes up and down, and it always goes between 1 and negative 1. All right, so whatever we plug in for x, it's going to be somewhere between 1 and negative 1. All right, so oscillates between b/w, 1 and negative 1. The other one, we already did that at the top. The limit as x approaches infinity of 1 over x is 0. So regardless of what value this first piece is, when we do the multiplication, we multiply it by 0, we're going to get 0 because anything times 0 is 0. So the 0 kind of overpowers whatever the sine of x was. All right, the limit as x approaches negative infinity, same thing, I'm going to split it up, sine of x times the limit as x approaches negative infinity of 1 over x. If we find the limit as x approaches negative infinity of sine of x, again, it's going to oscillate between negative 1 and 1. All right. This guy, we know that it's going to approach 0. So we're multiplying something between negative 1 and 1 times 0. We're going to get 0. So we know that the limit as x approaches plus or minus infinity, all right, is going to end up being, it's going to be 0. Okay, so the limit as x approaches positive infinity of sine of x over x equals 0. And the limit as x approaches negative infinity of sine of x over x equals 0. Now, if you didn't want to do it this way, what you could do is you could do it a second way. Before I do that, let me just mark down the horizontal asymptote is obviously going to be y equals 0. Okay? Now we can do it the other way. Option 2 deals with the sandwich theorem, which we focused on in the previous video. Option 2 is we can do the sandwich theorem. So what we can do is we can start off with just sine of x. We know that sine of x oscillates between -1 and 1. So I'm putting it between -1 and 1. This original problem, though, is sine of x over x. So what I'm going to do is I'm going to multiply this whole thing by 1 over x so that I end up with my original. And I'm going to get -1 over x, and then sine of x over x, and 1 over x. All right. And so what's going to happen is we can find the limit of each of these pieces. If we find the limit as x approaches infinity of -1 over x, we know that equals 0 from the previous problem at the very top. The limit as x approaches -infinity of 1 over x is also 0. Since those two pieces both approach 0, that means that sine of x over x has to also approach 0. So therefore the limit as x approaches positive infinity of sine of x over x has to equal 0. And then you can do the same thing for negative infinity. All right. So you can, the same holds true for as x approaches negative infinity. You could do your sandwich theorem all over again, but it's not necessary. The same holds true for the limit as x approaches negative infinity. We just did the positive infinity. We know it's going to equal 0. And then if you did negative infinity, it'll be the same thing. So it's up to you which way you like. Things to be aware of. We've kind of touched on these already. All right, so we just did this one. The limit as x approaches positive or negative infinity of sine of x over x has to be 0. And then this one we did in a previous note sheet, but the limit as x approaches 0 of sine of x over x is going to equal 1. These are going to pop up from time to time, so you'll want to make sure that you keep those handy. Okay, for number 4. So what we're going to do is we're finding the limit just as x approaches infinity. We're not doing negative. So I'm going to split this thing up a little bit. I'm going to do the limit as x approaches infinity of 5x over x plus the limit as x approaches infinity of sine of x over x. All right, this one the x's cancel out, so we're really just doing the limit as x approaches infinity of 5, which is going to be just 5. And then the limit as x approaches infinity of sine of x over x. We just did that up here. It's 0. So this is 0, and there's a plus sign in between. 5 plus 0, we're going to get 5. So the limit as x approaches infinity of 5x plus sine of x all over x is going to equal 5, which means that there is a horizontal asymptote at y equals 5. All right, so hopefully not too bad. And then with number 5, you can justify using the sandwich theorem. Okay, so what we can do is we're going to start off with just sine of x, because with sine of x, we know for sure it's between -1 and 1. From here, we need to get the plus 5x. So what I'm going to do is I'm going to add 5x to all three sides. Okay, so I'm going to add 5x. So I'm going to get -1 plus 5x, sine of x plus 5x, and 1 plus 5x. And then we got to get the divided by x. So now we're going to multiply this whole thing by 1 over x. So we get -1 over x, I'm sorry, -1 plus 5x over x, less than or equal to sine of x plus 5x all over x, and 1 plus 5x all over x. And what we can do is we can kind of split these up. All right, we're going to be finding the limit of each of these pieces on either end. So we're going to find the limit as x approaches infinity of this -1 plus 5x over x. This can split up into the limit as x approaches infinity of -1 over x plus the limit as x approaches infinity of 5x over x. The x's are going to cancel, making this approach 5. This we know it approaches 0. When you add them together, you get 5. And then you can do the same thing for the other piece. It's essentially the same except for the negative. So you got a limit as x approaches infinity of 1 plus the limit as x approaches infinity of, 1 over x, and then 5x over x. Okay, 1 over x, that's going to approach 0. This is going to approach 5. Add them together, and you get 5. So we just proved that it does approach 5.